Mm. Okay, so I want to be clear. This code notebook, the code notebooks I'm going to share here are for everyone, even people who've never coded before. I think a lot of us are about here, and I would put myself in that category. I am a beginner, maybe just a more expert beginner, but I want to make it clear, although I have some notes in here for more advanced people, even if you have never typed a line of code, this series is for you. I'm going to have some code notebooks, and there are links in the instructions of the video. So you can follow the instructions for episode 2. If you haven't seen episode 1, I suggest you watch that and go through the links. You'll get somewhere like here, and then you're going to run notebook 0 in this episode, as well as notebook 1. I'll load that up for you, and hopefully we'll learn some things. Now, after you run these, if you're a really beginner programmer, you're going to wonder, well, okay, so some stuff happened in my screen, but how do I make a program? How do I get to the point where, I make this thing that people can download and then they run it on their computers? Well, that's modern industrial programming. And to do that, you don't just need to know how to program, you need to know how to learn version control, which is essentially some kind of tool to work with other people who also write programs, and it just glue them together in a way that makes sense so that you don't write things that contradict each other. As I promised, I'll talk about version control in this episode. Version control. So what you've been looking at in these sort of notebooks that I've built is just a little part of what would make a normal modern industrial program. When you think of a program, you think of like something that has an icon, you click on, it runs. You don't have to run the code. It just does stuff for you. So, there are different parts of how you assemble something like that, and version control is a really integral part. I happen to hate that part. And I avoid it as much as possible, but you have to at least know it exists. So let's talk to someone who understands way more about version control than I do. It's a new segment on my show. It's going to be chatting with the experts.
Okay, so my name is Oleg Sivakon, and when I was little, I dreamed to be an artist. And by the time I grew up a little bit, I realized that it might not have been exactly for me, and so I became a programmer. And I've been doing that for the last 20 years. My particular area of expertise is ops and automation, and mostly in system programming. So I deal with mostly Linux computers, but I've also seen other computers too.
And can you talk about version control?
Sure, I can talk. Yeah, so but just to let you know how much of an expert I am in this area, I'll tell you this. There are people who are more expert in this in virtue of them being the authors of tools like version control, and I won't pretend to be one of those. I am the person who arranges for these tools to work for other programmers. I automate the processes in programming companies to make these tools work better or be less confusing or more automatic for people who work there. So you can think about me as being an expert user.
Okay. So can you explain what version control is?
Version control is typically a suite of programs, all of them jointly serving two goals. first goal is to keep your history of changes of a document, but more likely a group of documents. And second purpose is sharing your documents in such a way that you can keep track of what information was shared, what changes did you introduce to the documents, what changes belong to other people, and you have means to control which changes gets into different versions of the product.
Okay, what I love about version control is when you work with other programmers and you don't mess up each other's work. Can you talk about that?
Well, of course. The tools themselves, they don't necessarily ensure that. The tools are, well, again, tools. Yeah, so on top of tools, you also need to understand the protocol, the human protocol for using those. Typically, people using the tool agree on certain conventions. So for example, they would have particular parts of the version control repository dedicated to what they would call a master version or final version. And that would be a version where people are not allowed to go back and change history, for example. And so this would be the version that everyone takes as a gold standard, and everyone, whenever they want to make changes, they would base their new work off the version residing in this master chunk of the repository. And this prevents people from stepping on each other's toes and inadvertently deleting each other's work. So each person essentially works in their virtual copy of the entire project, but whenever they want to synchronize with others, they need to each one individually solve conflicts with the golden standard that everyone aligns themselves to.
Okay, so we have the screen up, so maybe you can just show some commands in Git, which is really popular for version control.
Oh, yeah, sure. So I'm going to use your notebooks repository for that.
Okay, go ahead. I'm not afraid.
Okay. So usually you would start at just having some code written, and then you, let's switch here as well. And then, so say this is all of your code belonging to the notebook. So you can see there's some notebook code, there's some README, and so on. And the usual way to access version control is to run some commands. And just to be clear, let's go to the same directory. Oh, just so you'll see that I'm not doing any kind of magic. I'm copying the name of the directory from here. And here we go. And see, that's the same directory, but this is Emacs view of this directory, and this is the shell view of this directory. So yeah, Emacs has a very good mode for working with Git called makeda, but in order to not complicate things further, I will only use the command line stuff. So,
Right.
so usually your work would be like this. So first of all, you want to sort of update yourself on what's going on here.
Git status.
Yeah, so you would do right, get status. And it says, well, it's all good. There's nothing new. We don't know about anything new, and all is perfect. So if I change something, for example, let's change something randomly, like I don't know, let's create a new file, and we'll call it new file txt, and we'll write here something. And we'll save it. And now you see here, we added this new file, and let's do the git status again. And now it says, well, look what happened. We have a new file txt. So if I were to continue working on this, I would do the following. I would add this file to my repository. Yeah, but okay, this was a little bit of a mouthful. I would add this file not to my repository. I would add it to the change set in the language of Git that would be called commit. I would stage the file that's adding it to a commit. A commit is a set of changes that I'm about to propose to others to incorporate in their work. So after I did git add, I can check git status again, and it will tell me that there are changes to commit. See, previously it was saying that I have untracked files, so it didn't know what I want to do with this file, because perhaps I edited it by mistake, or perhaps I wanted to ignore it. I wanted it to be locally, but never to suggest it to anyone else. Now it's sure that I want this file to be shared with others, but I have not yet confirmed this intention. So now I'm going to actually go on and confirm this intention. I'll say git commit. Okay, so unfortunately, because of how I've configured the system, this is not going to work, because it wants to use a term, it wants to use an editor to have a commit message, and my system doesn't allow that. So we'll do something to circumvent this problem, and we'll tell it like this. We will not review the changes, or you know what? I can actually show you how to review the changes using Emacs Magate mode. So here it tells me what the changes are, and if I want to commit it, I would do something like this. And here you can see Gate shows me what I'm about to commit, and here I can see what was the nature of each particular change. So I can, for example, fold it. If I had more changes, the folding would be more important to navigate this stuff. So once I'm happy with the changes I'm about to commit, I'll tell, well, this is the change I intend to share. I'm sorry, my space key is not exactly working. And here we go. Let's go back to our shell.
You're working in a lot in something that's pretty much like command line. People who just start out may be more comfortable in a GUI or graphical user interface way of interacting with the computer. But in the end, it's all the same in the sense that we're working on something in a way that our changes are tracked and controlled.
Yeah.
So that was version control, and you just can't build a solid program these days without it. at least a program of any size where you have more than one programmer working. Without it, it's just boom. Yeah. So now that I talked a little bit about what I feel are the absolute essential ABCs, the building blocks of modern programming, I'd like to talk about the future of programming and programming versus coding, using GIS as an example. Programming for imaging, medical imaging, is kind of like, in some ways, programming for GIS, Geographic Information Systems. Already, if you look at the code that's out there for geographic information systems, you can see they're starting to do a lot of convolutional neural nets. You know, they're into machine learning, and that's a lot of what's going on in code for radiology in terms of AI right now. So it really makes sense. I mean, what are we talking about? Image recognition in 3D off of a bunch of pixels or voxels. It makes total sense that the math behind this is the same. And I wanted to bring this up because I personally think that we're going to see in radiology and radiography a transition that is something like what happened in geography. It used to be that geography was a subject, okay, you studied, it didn't have much to do with computers. But now you see there are people out there studying GIS, Geographic Information Systems. So those are people who have learned some level of geography, but they also learn how to code. They learn how to deal with information in a geographic system in an organized and mathematical way. And it's a very specialized thing to study. But if you think about it, this could be applied to other fields as well. This approach where you have some people who learn how to cope with the information systems around stuff. Now, I know in radiology, there's already an imaging informatics fellowship, and there are also imaging informaticians out there who didn't go through a fellowship, but for some reason work in this field, and they might be more expert than people who have gone through a fellowship. You just never know with these things. Not a big fan of accreditation because sometimes people who don't have accreditation in computers know way more than people who do. But I think this is the direction, not just for radiology, by the way, but for many, many things, that we're going to see fields sort of spinning off that combine subject matter expertise and programming. Now, are the people who come out of a GIS program going to be expert infrastructure programmers? Absolutely not. They're just not. They're going to be like here, like this little baby with infrastructure programming. But I think we're going to see a split where some people have learned to program for a field and some people just become general programmers. And we'll call those people who program for a field coders, or information system specialists for that field. And we'll call people who can do general programming, networking, and build the infrastructure around modern computers, we'll call them the computer programmers. So lots of predictions. It's holiday season. 2020 will be upon us. I think this is the way we're going to go with a lot of scientific fields. Might take 20 years, but you know, I'm here from the future to tell you all about it. So leap into my other code notebooks and you can pause the video. I'll be back with commentary and just have fun.